Hello and welcome to Physics Doctor. This is Dr. Ghanshyam Tejani and let's start. Class 11, chapter number 4, Motion in a Plane, and the similar content is covered in NEET JEE unit number 2, Kinematics. And this is session number 9 of Kinematics. And this is part number 3. Part 3, we are talking about part 3, which is mentioned here, inclined projection. You may argue that inclined projection we did cover. Of course, we covered, but what we covered? We covered inclined projection at the same level. That means what? A body, if it is projected at some level, that means it is returning to the similar level. Level is not changing. But here we are targeting inclined projection at different level. Different level, that doesn't mean that level of uh, can say difficulty. No, it is not like that. It is a level at some two different height. Maybe object is projected at some horizontal position and it is resting at some height or maybe below some horizontal level. We are targeting this. And also we studied projection in the horizontal direction. Also time of flight, range, height, we studied and we will utilize these formulas as well as concepts here also. And how? By solving various NEET, JEE, JEE advanced questions, and we will formulate, we will build our base on it. First, let us again understand what is projectile. Of course, we studied this, but here repetition will help you to learn more in a more robust way. So, say for example, from the O point, an object it is thrown at initial velocity u. We know that we use small u for initial velocity at some angle theta with horizontal axis. At some angle with horizontal axis, we know that angle is theta. So such that object travel, or you can say take path, or we call this path as a trajectory. An object it is known as projectile. So it is subjected to two movement. One is horizontal movement, and second is vertical movement. We did study it, definitely this one, but let us again recall this. Say for example, so it is having u, it is thrown on xy plane, or you can say on air. So it is having two component. One is vertical component and second is horizontal component. And who stated this statement? The statement was came from Galileo. So here it is, if you take vertical component of this system, or you can say the force u, so we call it uy. Uy is equal to the theta which is not nearer, so we know that is equal to u sine theta. And similarly for the horizontal component of u, it is called ux, and is equal to u, angle is nearer, so we can call it u cos theta. So u, it is having two component, one is u sine theta and second is u cos theta. So projectile motion has vertical component and horizontal component. And when we talk about these two component, let us discuss again. So when the object it is having horizontal movement, suppose it is moving in the horizontal direction, we call it ux, and it is subjected to acceleration. Say for example, a, because of what? Because of gravity, ground. But if you see the angle between this ux and acceleration is 90 degree, that means it is not affecting ux. Therefore, ux remain constant. Ux remain constant. But in the case of vertical movement, object is going up with velocity uy, and which is subjected to gravity, which is in the downward direction. That's for minus g is used. And because of that, when object moves in upward direction, its speed reduces. Speed reduces, at initially it is u y. It when it reaches to top position, it becomes 0. Ui becomes 0, and gradually when it comes down, it again speed increases in the negative direction. See, therefore, this projectile motion is having two components. One is horizontal and second is vertical. Horizontal component is always constant, whereas vertical component is subjected to gravitational acceleration, and therefore it changes. It changes with time. So we have to understand this concept, and that will help you a lot to solve many different examples. So here vertical component of the motion is subjected to gravitational retardation, while the horizontal component remain constant if air resistance is neglected. See the condition, terms and condition is applied here. See, when you see any, if you purchase a mobile phone, there is a guarantee or warranty it is to be given, but there is a catch. Terms and conditions are applied. So here also terms is applied. Here what is term? If air resistance neglected. So we are not considering here effect of air. If there is a consideration of effect of air, that means path, it may not travel up to full range. It may travel up to this level, or path may be having somewhat different trajectory. But see, most of the objects are having a much lesser effect of air, right? So we can neglect at initial study wherever effect is not so high, or you can say negligible. Its effect on the range, on the velocity, on the speed, on vertical height. If it is negligible, we may neglect it and to avoid a complexity. So throughout the chapter, throughout the physics, we will be neglecting air resistance. So here, let's have horizontal component and vertical component. We did first for the u, that is the horizontal component is u cos theta, and the vertical component is uy is equal to u sin theta. Then we studied acceleration. Horizontal acceleration is 0 and vertical acceleration is minus g. Yes or no? Of course. And we are in the chapter where we are discussing kinematics and we are discussing motion. And we have equation of motion, three equation of motion. That is a one first one. V is equal to u plus at, s is equal to ut plus 1 of at square, and this is second, and third one is v square minus u square is equal to 2as. As I mentioned earlier, by using these three equation also you can solve all the problems of projectile, but it takes time. So it is better to remember some equation, not all of the equation, some equation. If you remember all the equations, if you are a genius, you may do it fine. But I do not recommend all the equations, because if you have more number of equations, there are possibilities that you may put up a wrong equation and you may get a wrong answer. We don't want to do that. Okay, so let's use the first equation that is mentioned here. U is equal to, sorry, V, that means final velocity or maybe velocity after some time, is equal to U at. We are talking about this equation, the first one. So see, this equation is for one dimension analysis, and we have here two dimension analysis. So we have to take this as a two dimension. So we can take one as a x direction, Vx, Ux, and A t. So Vx representing a velocity under, or you can say with respect to horizontal axis, and Ux, that is the initial velocity with respect to horizontal, right? So we know that ux is equal to, we already derived that ux is equal to u cos theta, and for horizontal a is 0. That means this term is 0. Second term is 0. So we can derive this like that: vx is equal to u cos theta when we take horizontal component. But when we take a vertical component, so that become vy is equal to uy is equal to ay. So we derive ay sorry, uy is equal to u sine theta, and this is acceleration along y, so become minus g. So therefore, it become vy is equal to u sine theta minus gt. So we derive two equations. We derive two equations from first motion equation. Let us derive two more equation from second one. S is equal to ut plus 1 of at square. So we can take s x as a horizontal movement, ux as a horizontal, and ax. Right. So it is just showing horizontal direction. That means it is showing x. It is showing value of x. So Sx is equal to ut plus 1 of at square. What is u? What is u? Ux is equal to u cos theta t. It is a scalar, therefore direction doesn't matter for the time. Ax, what is acceleration along x direction? Yeah, acceleration is 0 along x direction. So this term, second term becomes 0. Second term becomes 0. So what do we get here? We got here for Sx, you can also write here Sx is equal to x as a distance from origin is equal to ut, that means u cos theta t. You can have t and somewhat ut cos theta, so you can change this equation like that. And similarly, for the vertical movement, we can take sy. That means it is showing a vertical movement, vertical direction. This distance along y, so that is a y. So sy is equal to uy, t is a scalar quantity, ay. So sy you can write as a y distance from the origin, uy it is here, u sine theta, so it become ut sine theta, and then acceleration that become minus j. So equation that become sy is equal to ut sine theta minus 1 of gt. We can write equal to y. We can write this equal to y. So we got another two equation from equation of motion number 2, and we are here at equation number 3 of motion. V square minus u square is equal to 2as. So we can put here what? X direction, x direction, x direction, horizontal direction movement for that velocity. So Vx square minus ux we already have value for that, and acceleration, horizontal acceleration is 0. Therefore, Vx square is equal to ux square, and Vx is equal to ux. That we know Vx square is equal to u cos theta square whole square. And similarly, we can put here the values for the equation number 3, that we can put here Vy square uy square to a y s. And for the y, we have values for that. For the uy, there is a u sine theta, acceleration become negative. Therefore, vy square minus u sine theta square minus 2g sy. You can took sy in terms of y. So we got this equation. See, we need to repeat again and again to understand the concept, how to understand anything, whatever you want to learn. Again, some terminologies. So first is a velocity of projection. That means object, it is projected at some velocity, that is u. So you have to understand all the terminologies, right? If you misunderstand any of the terminologies, that means in the example calculation you may misjudge the example and you may turn into a wrong result, and we don't want to do it. So velocity of projection, that means the velocity with which the projectile is projected. Simply we can call it initial velocity. It is u, denoted by u, small u. In some of the books you can see that is denoted by v0. Whatever you wish, I recommend go with u, small u. And unit is meter per second. Second is angle of projection. That means object is projected at angle with horizontal axis. We have to consider horizontal axis, and this angle we do not take as alpha, but we take as a theta. Alpha we take when during a projection. During projection, if this object is projected with horizontal, we take as alpha. alpha. Otherwise, we don't take it. Initially, we always take this as a theta. Then trajectory, path traced by the projectile is termed as a trajectory. That means whatever path is taken, if it is thrown on air, so path taken, that is taken as a projectile. Then horizontal range, that means see horizontal distance through which the projectile travel during its flight. The object is thrown from this point O and it is on air. It is on air, and here it is resting. So the total travel, or you can say horizontal distance travel, it is called range. It is called range, not a total travel, but horizontal distance. We call it the displacement, and that is known as range. And the time of flight, that means time taken, right, during this projectile movement, that is known as time of flight. And one more terminology, we call this y at become maximum. It is we call it as a maximum height. We call this as a maximum height. So these terminologies you have to remember. So we already studied first one, that is the inclined projection on level ground. Inclined projection on level ground. So object is thrown right from the horizontal, maybe ground, and it is arriving or reaching at the ground at some different distance. So that is inclined projection on level ground. We did this. We our part number 1, it is for the inclined projection on level ground. Then horizontal projection from certain height. So we did in our part number 2 of this session. Object is thrown from some height horizontally and it is projected like that. Maybe from the plane or maybe from the building, top of the building it was thrown. So we did 1 and 2, and now this is third number, inclined projection with a point of projection and point of strike at a different level. That means what? The object it is projected, maybe one from one level it may go below this line. It is not like that. May touch below this line, below this level, or it may it may touch at some height. So you can assume that the object which is thrown on maybe from the ground to uh, maybe first floor, second floor, or maybe from the ground to maybe some a lower height. So we are here, we will be studying this part. And the fourth one, inclined projection on inclined plane. That means if we throw an object on inclined projection towards a slope, positive slope, or maybe we may take on the opposite side, we may throw object from this position and at negative slope. So this will be the next part. But here we will be talking about inclined projection with a point projection strike at a different level. Wow. So how we are going to study this? So by taking various examples. So let's have example number 1. See, you have to understand the example, and after that learn, you should draw or you should convert this into a graphical form. So here it is given example number 1, from the top of the building, say for example one building, it is given here. This is the building having some height. It is given here 25 meters. So let's have 25-meter height. So from the top of the building, 25-meter tall, a ball is thrown with a velocity 40 meter per second. That means it is initial velocity. That is given by initial velocity. At an angle 30-degree with horizontal. See, here object it is not thrown at horizontal, but which is thrown at reference with the horizontal axis. Let's consider this as a horizontal axis. An object is thrown at with this reference. The object it is here. It is thrown at initial velocity u, and this angle is given 30-degree with horizontal, right? So we need to find first a time taken by the ball to hit the ground. So see, ball will travel like that and at below 25 it is somewhere here, ball strikes on the ground. So it is time taken. So whatever time is required for this entire journey, it is to be calculated. So this is the first one, we need to have time. First we require here time. Second one, here B, the distance from the foot. That means this is the foot, this is foot. Distance from the foot of the building of the point where ball hits the ground. Where the ball hits the ground, we know it. So see, this is a foot or base of the building, and this is the position where ground is. It is ball is hitting. So we need to find this distance, and we better know this. We call as a range, or you can also call as a x distance traveled, whatever you wish. So here take g is equal to 10 meter per second square. So mostly in JEE NEET examination, you can take g is equal to 10 by default majorly. So it is mentioned here that let us again understand. So from the top of the building, 25 meters. So this is height of the building. This is a building. Let us understand. This is a building, and height is given 25 meter. This is 25 meter is height is given, and at an angle theta, which is mentioned here, theta 30 degree at initial speed. At initial speed, 40 meter per second, ball is thrown. Right. So it possesses two velocities. One is u cos theta, that we call it u x horizontal direction, and u sin theta, that is vertical. Right. See, remember that in this manner, theta, if it is theta, a nearer angle always pick cos theta. A nearer angle always pick cos theta. Right. So we need to find first is time required for this flight. So we know it is time period, and second is distance from the bottom of the building to the strike of the building. We can call this as R, or we can call this as X also. Whatever you wish, you can go for any of these two. So you may pause the video and you may try by yourself. See, if you can solve unsolved examples, then only you can build the confidence. See, watching these videos or any other videos, this won't much help you, right? At after maybe certain level. See, if you studied a basics or maybe have calculated some examples, so I always recommend that you try to solve by yourself. You may have a different method, that's okay. You may have error, that is also okay, right? From the mistakes, from the errors, we have to learn, right? So let's solve it. So see, first it is given building height is given, height is equal to 25. We can take negative, or it can we may avoid also. You know that where to take negative, where you cannot. You need not to take negative, you know very well, right? I taught you many a time. We will also learning, keep learning on that, when you can take negative or when you cannot take negative. Or if you take negative every time, in this case also you may not be having a wrong answer. But if you have just remembered equation, then at that time you may have difficulties. But if you have understood concepts, then you will not be in a trouble. So here it is given, h is given minus 25, you can say 25 meter height. U, that means initial velocity, it is given 40 meter per second at an angle theta is given 30. See here, when you see, you just need to have first three equations. You have to have three equations for the motion, right? So ux is equal to u cos theta, uy is equal to u sin theta, that we know it very well. And that sx, we derive this equation from where? See, when we talk about distances, here we just need a distances because we need r and we need time of flight. So we need equation that is majorly, we know that s is equal to ut plus 1 half at square. See, from this equation, you can derive two equation, because this equation is for one dimension. We are solving problem of two dimensions. You can take Sx, Ux, and A. When we talk about horizontal acceleration, so it is always 0. Ux, we already know Ux is equal to U cos theta. So Sx become U t cos theta. So this equation is here mentioned. Sx is equal to ut cos theta. Similar, we can take for the vertical component. For the vertical component, that become sy. Sy, Uy, Ay. See, you may remember this equation also, but again, I do not recommend this remembering. The reason is that there will be so many examples after completion of this course. You will be having equation from physics, equation from chemistry, mathematics also, and you may get confused with that, right? So you should learn the concept. So rapidly you can directly convert this equation to a required form within a second or within maybe few seconds, 5 6 seconds. You may take. You may not need more time than. So Sy, that means vertical distance. Sy, that means vertical distance. You can call Sy is equal to y also simply. Then Uy, that is u sine theta, and vertical acceleration. We know that has become minus g. So ultimately, you will be having this equation: Sy is equal to ut sine theta minus 1 of gt square. See, whenever you have a distance as a requirement, range or height, you use equation of s. S is equal to ut plus 1 of at square. So now what next? What next? So we have equation distance. We have distance. So we have vertical height of the building h is equal to minus 25. See, we initiated the ball from this A point and it was thrown up. So you just need to consider height to the ground, height from the ground to the point A. And here, see, when you consider a movement of an object, a two-dimension movement, object is going up and moving down. At that time, you consider height as a negative, right? So at that time, we have to consider because our x starts from this position and this below this, it is to be considered as a negative value. So here in this case, whenever you see the two movement, object is moving up and down, so height to be considered as a negative. But if it is just a single movement, that means object is moving up only. So at that time, you can take height as a positive, or all other values you can take as a positive because direction is not changing. So your answer will be correct. So here s y is equal to u. We have value of u sine theta. So sine theta, theta is angle is 30 degree and minus 1 of gt square. G is tan t square. So we have here equation. We know that value of sine 30 and this all. Right. So we get equation t square minus 4t minus 5 is equal to 0. You just solve this equation and you will have t is equal to 5 seconds. That means time taken for this entire journey, right? Starting from this point to the object falls, or you can say object strike to the ground below 25 meter. So the total time it's taken 5 seconds. Total time is taken 5 seconds for the entire journey. So we got the answer for the point number B, distance, not point number B. We got time A. We got time. We got A, that is the time. So time is equal to 5 seconds. Now what next? See, now is we need to find here the distance from the root of the building of the point where the ball hit the ground. That means the distance from O to C. That is the range. So see, horizontal ux, or simply you can say sx is useful here. So sx is equal to ut cos theta. We can use this equation. So sx it is giving x, or simply you can say r, that is giving range. R is equal to ut cos theta. What is u? What is u? For t, t it is taking time. Now we got a value of time of flight. So t, to start from this journey from point O and end this journey C, during this entire journey, it is taking 5 seconds. So put this value here and your answer will be 173 meter. So this is solution. This is solution R. We got here 173 meter, right? Again, I suggest that you again solve this example. This kind of examples are very popular and you may have this kind of example. You should repeat the process again and again. So we have one more example, and this is from JEE 2003. As I mentioned, see, similar kind of questions will be there in the JEE. So what is mentioned here? A boy playing on the roof of 10-meter high building. Let's draw building again. This is a building which is having height 10 meters. Simply, I suggest that always what you do, you read the question, and during reading, you should construct the sketch for that. So that will help you a lot to understand the question. So, boy playing on the roof of a 10-meter height building throws a ball. He throws a ball with a speed u initial, that means initial speed is u is given 10 meter per second at an angle 30 degree with horizontal. See here, again it is not thrown horizontally. See, whenever you see the questions of height, it doesn't mean that ball is thrown horizontally. We should read the question and then only we should derive a conclusion for that. And reading a question is the most important thing in the physics or in the chemistry, also in the biology also. Otherwise, you may misjudge the question. And this is one tricky question. Looks very simple, but it is actually tricky. What happened here? It is mentioned that along the x direction, this is x direction, the object is thrown at u 10 meter per second. The velocity is given 10 meter per second is given, and the angle is given 30 degree. Angle is given 30 degree with the horizontal. See, now it is how far from the throwing point will the ball be at height 10 meter from the ground. See, from the reading, most of the students, what they do, right? Even person like me also can do. The ball is like traveling; it will reach like projectile. It is reaching the ground, and it reaches to the ground, and so it is horizontal distance. How far? That means this is the range. This distance is required to calculate. You calculate this distance, right? And that you call as x or r. And see, this answer is wrong, but this wrong answer will be there in the option because here intentionally it is mentioned. See here, the red portion you read again. How far the ball? How far from the throwing point? That means throwing point. We can call this as a O point. Throwing point. Will the ball at height 10 meter? See, here it is asked that at height 10 meter, at height 10 meter, at height 10 meter. So this point, let us call it is a P point at a P point. So for that distance, you just need to find the distance. So your R is not this one, but the top one. This is the R. And this kind of tricky question, like looks very simple at a first instant. You definitely think that this is the range, it is this one, but this is not the case. This is not the case, right? So while reading the question, you must take due care. Otherwise, you will turn into a wrong answer. So let's again read the question. A boy playing on the roof of, this is height is given 10-meter high building, throw a ball with a speed 10 meter per second at at an angle of 30 degree with the horizontal. So here drawing is there. So building height, this is our building, this is building at 10-meter height, at 10-meter height. Object is thrown at some u velocity and the angle 30, and the object is, we just need to have this. If you neglect this portion below, so your question is like that: object is thrown from O with some u velocity, and it is just traveling, it is hitting the ground at some distance 30 with the same height. Yes or no? Now this question is now become halwa, and now it is very simple to you. Let's solve it. So four options are given, as in NEET and JEE. You will have four options: uh, 5.2 meter, 4.33, like that. So solution h is equal to minus 10, u is equal to 10 initial velocity, u is given 10 meter per second, and theta is given 30 degree. Always take a habit. You write unit after unit. Always keep a habit of writing units. Otherwise, you may have a difficulties afterwards. You may have a wrong answer, and wrong answer are always available in these options. So see, you may take equations like we did in the previous example also, or you may remember this equation because this, now it is very simple. We also derived these three equations: t is equal to this, and r is equal to this, h is equal to this. this, you also remember these equations and you try and again repeat this. Repetition is the key here, nothing else. So here what we need, here we need R range. So let's take R is equal to u square sine 2 theta by g. U is equal to 10 square. U is 10. So 10 square sine 2g, that become 30 multiplied by 2, that becomes 30, and g is 10. So 1g is cancelled and R is equal to 8.66 meter. Is it given? R is D answer. D is the correct one. See, you have to read the question, right, to get your conclusion. Otherwise you may turn into a wrong question, and you may also see that wrong answer will be there in the option. Or you may have, as I mentioned earlier, velocity ux is equal to u cos theta, uy is equal to u sin theta. You can take sx is equal to ut cos theta, and you may derive these two equation or remember these two equation, whatever you want. And you can take distance. So see, we are starting and we are ending here. So this distance becomes 0. You can put this distance 0 here and put all other values. U is 10, sine is 30-degree, right? So you can put these values here and you can derive, this will be the equation. You may derive this, all will be there. So you can get t is equal to 1 second, and then you put this value in as x. So s is equal to x ut cos theta, and you will be having the similar answer. You will be having similar answer. So you can use any of the method, but you should know all the methods. You should know all the methods very well. Example number 3, it is here. I think you should pause the video here and solve by yourself and to boost your confidence. And your correct answer will bring you happiness. So example number 3, it is here. From the top of the tower, 156-meter height. So height is given 156.8 meter. A projectile is projected with a initial velocity. So initial velocity is given 39.2 meter per second in a direction making angle 30-degree with horizontal. See, so here the similar case. This is our building. From the top of the building, object is thrown with the horizontal. So this is x direction, 30-degree. Find the distance from the foot of the tower where it strikes, the ground, and time taken to do so. So similar cases here. Object is moving in this case, and not it is making like that, but and object is on the ground. It is like that. So it is the distance we need to take, we need to find, or we can call it R. We can call it R. So here ready-made drawing is given to you, but you should bring your drawing. So this is 156.8 meter height, and the object is thrown 30-degree with u 39.2 meter per second. And so this is not R. Here it is given that from the bottom base to the ball strike, so that is R. Now I think everything is must be clear to you. So we know that h is equal to 156.8. You can take this as a negative. Fine. U is equal to 39.2 and theta is 30-degree angle. Now we know that whenever we throw an object u, so it has two component. Ux is equal to u cos theta, and vertical is u sin theta. See, I am repeating this again and again, right? The reason is that so such that you can get an habited with this. You should have habit of repeating this item. So initial velocity, we know that ux is equal to u cos theta, uy sin theta. And when there is a distance, we need to have a distance. So our equation for the distance is useful here. So which one is equation for the distance? S is equal to ut plus 1 half at square. This equation is useful. We can take derive sx. You can take x, ux, acceleration along horizontal, as well as you can take for the y, right? So you can get this two equation will be there. Sx is equal to ut cos theta, sy is equal to ut sin theta minus 1 half gt square. So this two equation will be there. Now we just need to put our values. Just we need to put our values, right? So we need to have r. So given data, it is a vertical height is given. Vertical height is given minus 156 8 minus, the reason is that because our, see, reference point is here, the top of the portion reference. This is our reference, and this is below reference. So therefore, it is minus negative 156.8. So we can put here SY 156.8, U is given 39.2, sine 30 is given T, and you will have equation 1 by 10 T square. So T square minus 4T minus 32, that is the equation you can get, and you can get T is equal to 0 and T is equal to 8. There will be two answers will be there. So initially time is equal to 0, right? You will get, and another will be this once it reach at the final destination. Time is 8 seconds. So this equation is utilized. We have one more equation for that, and let's use this equation. Sx, that is we call it horizontal distance. Sx, that means horizontal distance. Sx is equal to Ru cos theta. R, we can put U is equal to 339.2 and T is 8 seconds. Now we know value of time. See, value of time is very important. And cos theta you can put here, and the answer is 271.5 sec 1 meter. So simple, so simple. I think you must have compared your answer with this, and you must have got your correct answer. We have one more question. Right? Do not see the drawing. Let me just read the question. A bullet is fired from a height of 120 meters. So let us have just, this is our ground. This is our ground, and one soldier it is at some height, and this soldier it is fired a bullet at some height. This is 120-meter height. So we can take at, this is h height, right? So 120-meter, and with a velocity, initial velocity is given u kilometer per hour. So you need to convert this into meter per second. That is required, but that may not be required also. I've read the full the question and then you decide. 30-degree upward. See, 30-degree is very favorite here. Again and again, in the fourth example, we got 30-degree. Neglecting air resistance, if it is not mentioned, neglecting air resistance, even though we will neglect air resistance. So find total time of flight. So see, object, it is, and soldier, it is here, soldier is firing a bullet at 360 kilometer per hour at some angle 30, and the bullet is traveling like that, and it touched to the ground at point B. So for this, during this total, we need to have a total time of interval, then horizontal range of the bullet. That means, see, from the point A, what is range? That means it is from the B, point A to B, in the horizontal direction. We need to identify. C is maximum height reached by the bullet, maximum height reached by the bullet, and velocity of the bullet just striking the ground, just striking the ground. See, you must have remembered three equations previously also, but see, that equation give movement from A to D only. But here this is the below ground. This is the below ground. So that equation directly you cannot use. Without understanding the concept, you just remember that equation and you hope that you will get the correct answer, though your hope is wrong and you are never going to get the correct answer. So how it works? First, let us identify height is given, so we can take minus 120 meter. U is initial, so 360 kilometer. 1 kilometer is equal to 1000 meters. So you just multiply by 1000 on the above portion, and the below it is denominator, it is given in the hour. So hour is equal to 60 minute, and 1 minute is equal to 30 seconds. So become 3600. So divide this by 3600, so you can get 100 meter per second, and theta is given 30. Now what next? We have horizontal component ux. This is ux is equal to u cos theta, and that is another component uy is equal to uy. It is u sin theta. We know that very well. See, when we are here required to have, first we need to have distance, right? So for the distance, we need equation S is equal to ut plus 1 half at square, and we can take horizontal component and vertical component one by one. So it becomes Sx is equal to ut cos theta, Sy is equal to ut sin theta minus 1 half gt square. See, this you know very well, so I'm not repeating in a full detail, but you repeat every time. So put the value of, see, we have value of this y0, it is should be minus 120 because it is below x axis and it is a full angle, it is going up and then it is moving down. So therefore this y you should take as a minus 120 because our reference, this is our reference, ref, short name. U is equal to 100 meter per second sine 30t, and equation is t square minus 10t minus 24 is equal to g low. You must solve this equation. So t is equal to, you will be having two answers. T is equal to 0, that represent point A, and t is equal to 12 seconds, that represent point B. So we got time was it asked, velocity was asked, maximum height is asked, and then horizontal range of the bullet is asked. So t is not asked. So now what next? We can got range by using this equation. Sx is equal to r, or you can say x is equal to ut cos theta, and put the values. T we got just now 12 second. That means what is the range that we need to find? Cos theta we have values. So 100 multiplied by 12 cos theta. So it gives range is equal to 10660 meter. So we got range. So we got horizontal range. We got horizontal range. Yeah, time was asked. Yes, A was asked. Yeah, how can you make such mistake? A teacher can also make such mistake. I'm not a god. Even God have certain mistakes, or may not. I don't know. So here we got A, B. Now we are at C. Maximum height reached by the bullet. See here, it is difficult to get height from this position, or you need to have equation of trajectory. But see, you just forget the below portion. You just start with point A and D. Start with A and D, so you can get 120 plus this height. It is, I think, much convenient to get height in the such question. So we know the h is equal to u square sine square theta by 2g. Put this value here, put all the values here. U is equal to 100, sine becomes sine 30, g become 10. So your answer is 125. So answer is 125. So answer is 125. See, 125 is this distance, 125. We need to add 120. Right. So maximum height from the ground, that become 120 plus h is 125. See, in the examination, you will see that 125 answer will be there because the IIT person are very smart and they will put this in that, right? So such that they hope you will make this mistake, but do not make it. Do not make it. So we got first time, we got horizontal range, we got maximum height. Now velocity. Velocity of the bullet just before striking the ground. That means velocity at point B. Velocity at point B. See, we need to find horizontal velocity at point B. V we can call B. Let's call B, or let's call V final X, and another will be there Vy. We know that become Vy become negative in the downward direction. We know that, right? After it reaches to point C at velocity, vertical velocity becomes 0, and then after velocity become negative. Therefore, it is downward direction. So now what? Now what? We have another equation for the velocity. V is equal to u plus at. We have V is equal to u plus at. So horizontal component V is equal to u become V is equal to u plus at. You can take x is 0. Ux is equal to u cos theta, that we know very well. So this is the first equation. And similar, you can put y, u, y, u, y, u, y, a, y. Ay is become minus g, uy become u sine theta. So we have here another equation. Vy is equal to u sine theta minus gt. So we need here ux and uy. We know that ux is remain constant, right? So what you do here, I simply suggest that you get your answer, you get your Vx, Vy, then you take V as a mode under root Vx square plus Uy square and put your answer in the comment. Example number 5. See, a body is projected horizontally with a speed u from the top A of a plane ABC inclined at an angle 30 degree with the horizontal. It strikes the plane at point P at a distance AP is given by C. First, you have to understand the question, right? See, this is the question where it is not like you may assume that the body it is projected from some angle and it is striking below a certain level. See, this is not the question for that, and that's why I bring this a different question from the our part number 2 where the body is projected horizontally, right? Just to recall that concept, otherwise you may have difficulties, right? See, you may solve individual problems at a time of learning the concept, but otherwise after that you should have mixing of all the questions. After all, during your examination all the questions are together coming, and you don't know that the question is from trajectory or question is from any other topic or whatever. You have to understand that part. Therefore, I bring this question. So here, see, body is projected horizontally with speed u from the top. So say for example, this is top point A. Often plane ABC incline angle 30 degrees. So here it is given the plane, or you can say it is given a triangle. It is given a triangle. It is projected like that, or you can just see the drawing which is given here. So it is point A from where object is having initial velocity u along the x direction, and see it is abc, you can see it is a plane, and here the ball is moving in the horizontal direction and strike. So it is definitely following the trajectory, right, for the projectile. But see, you may consider this example as a ball is thrown from the height and it is going in the angular part or incline part. But see, that equations are very bigger and you have to remember that equations. Definitely it is difficult to remember a big equation, but you can solve that example by using that our previous part number 2 when the object is moved in a horizontal direction. So options are given. So here object is moving from A to P, horizontal movement is x from point origin O, we can say A point, or you can say D point to P point, that distance is x, and from the D point to the A point, that distance is given y, right? It is very much understood. And we need to find distance AP, and this is triangle, so we can call it AP is equal to under root x square plus y square. Ultimately, you need to find x and y. Ultimately, we just need to have x and y component of this movement. So theta is given 30 degree, theta is given 30 degree for the angle. See, if this theta is 30 degrees, so ultimately z that becomes z, and that theta is also 30 degree. So we know that initially ux is equal to u cos theta, uy is equal to u sin theta. We know this terminology. So for the distance travel, we know that sx is equal to ut cos theta, and when there is a movement along the horizontal axis, right? Horizontal axis. So for this angle becomes 0. For this u, this theta becomes 0. So we know that when s is equal to ut plus 1 of at square. See, here when we talk about horizontal movement, sx is equal to ux ax. And for that u is equal to ux and uy is equal to 0, because ux is equal to u cos theta, theta is 0, therefore u, and uy is equal to u sin theta, sin 0 is equal to 0, right? So we repeated this many a time, therefore as x, for that horizontal component become u, that become u, and the cos theta it become 1. So as x is equal to ut, similar as y is equal to ut sin theta is 0, and g become minus g. So it become minus 1 of gt square. So ultimately we can have as x is equal to ut, and you can derive from this t. T is equal to x by u, and you can put the values of t in this equation. So we can put values of t in this equation. So we can eliminate t from the data, and y is equal to 1 of gx by u square. Simply you can put gx square by 2u square. And similarly, if I take this angle tan theta for this triangle tan theta, so tan theta, if this is the angle theta, so this angle should be theta, that both angles should be theta. That we know very well. So what is tan theta? Tan theta is equal to opposite side AD. So tan theta is equal to opposite side AD divided by dP. AD by dP, AD is y, dP is x. So y, you can just have y is equal to x tan theta. Oh, oh, oh. So this y is equal to x tan theta is equal to gx square 2u. So we got value of x, we got value of y, and from that t is eliminated, right? T is eliminated. See, in our equation there is no t, so t is eliminated. Now what next? See, what is our requirement? We need AP. We need AP, right? We need AP. So AP is equal to under root x square plus y square. So AP is equal to, you can just put value of y and x. You can put value of y and x. So x square, x is equal to, you can take x tan theta, you can put here, and just take x outside. You can see you have value of x and y, you can put whatever manner you wish, right? You can go for that. So AP is equal to x, you can put value of x here, and what is 1 plus tan square theta is equal to sec square theta, and if you take in root, that means it becomes sec theta. So here it become x is equal to u 2u square, that we already derived, tan theta by g, and it becomes sec theta. We got AP. And what is angle? Tan angle. What is angle? Tan 30 and sec 30. You can divide. You may have. You may convert into cosec also if you wish. And ultimately, you will have AP is equal to 4u square by 3g. AP is equal to 4u square by 3g. So this is answer, is correct answer. Isn't it easy? It is actually. May look difficult, but I think you should repeat this again, so you will build confidence on you. But this kind of questions are usually asked during NEET JEE and JEE Advanced. So you have to be ready with this. Oh, we have one more question. Example number 6. A cricket ball thrown by a fielder from a height of 2 meters. Say for example, fielder is standing at some height, Here it is there, and ball is thrown at a height 2 meters. So height is given 2 meter. You can take this as a negative. At an angle 30 degree, 30 is very popular here. See, 30 degree horizontal. So this is our horizontal axis x, with an initial velocity 20 meter per second. See, with an initial velocity 20 meter per second, hits the wicket. So there is a wicket, right? There are three stumps which is called wickets. Hits the wicket at a height. So it is not hitting at the ground. See, it is not hitting at the ground, but it is hitting at some height 0.5 meter from the ground. How far was the fielder from the wicket? So we just need to have range. We need to have, say for example, this point is A, This point is B, and we need range, horizontal range, this distance. This range is we need to have, and mostly students make a mistake by taking this height is equal to -2, but we have to take net height. See here, ball is not touching the ground, but it is at some height, 0.5 meter. So that height we have to take is equal to 1.5 meter. Minus, you can take minus 1.5 meter. So that is the only difference trick. So h is equal to 2 minus 0.5, that become minus 1.5 meter. U is 20 meter and theta is 30 degree. Now we got it. So we have horizontal component and vertical component of velocity u, right? So it become u cos theta, that is a horizontal component, and u sin theta become vertical component. We know that, see, the angle which is far away, so that become 20 sin theta, and the angle which is nearer, for that we write 20 cos theta, right? So see, you have to remember this part. And here we need a distance, so we need equation S is equal to ut plus 1 half at square. Take component, horizontal component and vertical component for this equation, and you will have this equation with you. Sx is equal to u cos theta, Sy is equal to ut sin theta. So Sx we can call horizontal distance, we can call this is equal to x or range, and Sy we can call vertical component, Fy. So what next? Put the values here for the Sy, this equation. Sy is equal to net distance vertically. So that become 1.5, negative direction because it is below this reference line. So minus 1.5 is equal to u is 20 meter per second sine 30 minus 1 half. So you will have equation t square minus 2t minus 0.3, and you should solve this equation. So what will be there? T is equal to 2.2 seconds. You will be having two answer. T is equal to 0, or maybe sometime you may have T is negative, but negative is not possible for time. So T become 2.2 seconds. But what we need here, we need this range, horizontal range we required. So horizontal range equation, we have one more equation. This is the equation Sx is equal to ut cos theta. Sx is equal to r ut cos theta. We have here put the values of t. U is already there, 20 meter per second. Theta is there, 30. So put here all the values here, and you will have r is equal to 35 meters. So range is 35 meters. Range is 35 meters. So like that, you need to solve this kind of questions. Should we go to next one, or you want to repeat? Yeah, you can repeat by going back to the video. It is a video, and so you can forward the professor. You can rewind the professor all of with your hand. You can do all of this. We have one more question. Oh, see here, gravel. It is given. So this is a gravel. So for that, some student may not know what is gravel. So for that, I just bring this image. You know that very well. So this is gravel in the quantity. Gravel is thrown into a bin. Gravel is thrown into a bin from the top of the conveyor. See, conveyor, that means it is just conveying, or it is just carrying that this gravel or stones or maybe any item. So it is just a belt, which is we can consider as a belt. If you see the top view, so it is having a belt, and it is having so many items on that, and it is moving, and with that it take the product. So here inclined conveyor is given. Here inclined conveyor is here. The gravel which is moving with this belt, and here it is released. Here gravel is released. So it is moving with some velocity of the belt. The object moves with the velocity of the belt. See, we discussed this kind of velocity part during our, I think, session number 3 or 4, right, in both the sessions. So if you want to have more details, I think you should refer to that videos. So what is mentioned? Gravel is thrown into a bin from the top of the conveyor. Refer figure is given, so congratulations. With a velocity 5 meter per second. See here, velocity of gravel, it is 5 meter per second. 5 meter per second. That means the object which is thrown, that initial velocity must be 5 meter per second. After that, it may reduce somewhat, but initially it is having 5 meter per second. You can do experiment, right? You are driving your car. Say for example, you are running your car. This is the car, and this is window, and this is lights. You are running a car at maybe 100 kilometer per hour. You open the door and jump outside. Your initial velocity will be 100 kilometer per hour. So all the practicals are not required to do it. You understand it very well, right? I am sure that you are not going to do it, right? And do not blame me for that. It is not suggested for you. So here, initial velocity of this gravel, that is a u, and that angle is 50 degrees. So for that also, it should be 50-degree. There is no change with this. So gravel is thrown into the bin from the top of the conveyor with a velocity 5 meter per second. Determine time. Time from this point A, time from point A to it is reaching bottom of the bin, right? So this net height, this height is not required. This height is not required because it is reaching bottom of the gravel, bottom of the bin, not gravel. Gravel is this. This is gravel. So we need time. First, we need a time. We need a time. Time. Oh, time is very important. Second is horizontal distance from the end of conveyor. See, horizontal distance we need from this end of conveyor means point A. We need point A distance from the point A, not from the start. Not from the start, right? So do not make mistake. Do not go for triangle trigonometry and find this distance. It is not required. This is not required. So the horizontal distance from the end of the conveyor to the bin where the gravel strikes. So that distance between A to B is required. That is our range. And velocity at which gravel strikes. So we need velocity. So there will be two velocities. One is vertical velocity and another is horizontal velocity, and it becomes negative vertical velocity. Oh. So we know that h is equal to minus 10 because it is throwing from this position. So h is negative minus 10. Theta is 50-degree. And initially u is equal to 5 meter per second. Then we have equation horizontal component ux is equal to u cos theta. Vertical component of the u, this is u cos theta, and the vertical component is u sin theta. Wow. Then distance are required. So what I suggest that s is equal to ut plus 1 half at square. Use this equation. So we got two component. One is horizontal component, another is vertical component that we did several times. So not repeating now. So we will have two equation. Sx is equal to ut cos theta. Sy is equal to ut sin theta minus 1 half gt square. Oh, excellent. Now what next? Put the values here. Height is given. So Sy is equal to negative height. So Sy is equal to minus 10. U is 5. Sin theta t is required 1 half 10 t square. So what do you have? You will have equation for that. And you solve this equation, you will have t is equal to 1.87 second. Usually sin 50 is not so popular. So generally sin 50 is a very rare case. It is not there mostly. Otherwise sin 50 in the terms of angle you will be having answer. There we need to find range. So we have equation this Rx, Sx, it's showing a range. So range show is ut cos theta. Put the value of time t and u was initially it was there. So it become 5 multiplied by 1.87 cos 50, and this answer is 6 meter. Now what next? Velocity we require to have velocity. So there will be two velocities. One is vertical component. Final velocity Vy, that is a negative, and another will be Vx, that will be initial velocity. You can take u cos theta. So we know that equation of motion v is equal to u plus at. That is the first equation. We can take horizontal component, we can take vertical component. In the horizontal component, no acceleration is taking place. So u Vx is equal to u cos theta and Vy is equal to u sin theta minus gt. That we know. That we know. So Vx is equal to 5 cos 50. Vy is equal to 5 sin 50. Put the values here and you can Vx is equal to 3.2 and Vy is equal to minus 14.5. See, as I mentioned earlier, Vy it is showing negative direction, right? So if you take direction like that, so you will have angle. You will have angle, right, with respect to horizontal. So how to find this angle? Or tan theta. Tan theta is equal to Vy by Vx if you want. And for the velocity, you just need to have under root 3.2 square plus 14.5 square. So answer is 14.88 meter per second. Right. So tan theta is equal to Vy by Vx and comment your answer after getting your angle. Oh, we have one more example. Example number 7. Soldier fires. Oh, bullet. Soldier fires a bullet. Let's do gun. This is gun. Oh, it looks like finger. Oh, it is advanced gun. Soldier fires a bullet with velocity. So initial velocity is given u 31.231.32 meter per second at an angle theta upward. Right. So here it is given. It is given. Let's take gun here. Theta. It is at an angle upward at initial velocity u. So soldier is here at some height upward from the horizontal from its position on a hill to strike a target which is 100-meter away. So here let's again recollect the story. A soldier fires a bullet with a velocity u, initial velocity 31.32 meter per second at an angle theta upward from the horizontal. That means it is making some angle with horizontal. This is theta from his position on a hill. So he is on hill. He is on hill. Hill. So at some hill, he is here. Soldier is here, and it is providing some angle theta with horizontal. And target is somewhat here at 50 mm below. So this target is 50 mm below, somewhere here, 50 mm below, somewhere here, 50 mm below in position. Find the angle of projection theta. What should be theta? So to hit this target, hits it target. So this distance is also given. R is given 100 and height is given 50. Means you can take y. Right. So again, the soldier is here at some hill and it makes an angle theta. Makes an angle theta. And initial velocity is u. There is a target. Let's call this point as a B, and soldier it is having at point A. So soldier wants to target this point B, and the point B is 100 meter away. So we can call R, and this is height. This is negative height. We can call. Okay. So given is h is equal to minus, not minus 10, but it is minus 50. Minus 50, u is equal to 31.32, y is equal to minus 50. So this one height is not required, it is given already. You can take h. X is equal to 100, or you can take r. Theta we need to find, velocity we need to find. So we know that two components are available. Initial velocity ux is equal to u cos theta, uy is equal to u sin theta. And see here we need equation of trajectory. So we have equation of trajectory. X y is equal to x tan theta minus gx square 2u square cos theta. You can try our previous method also. You will get answer, but somewhat longer process will be there. So that equation of projection we did twice in the our part number 1 as well as part number 2. We need here theta. So another equation is also there without angle that we are not going to use here. So what next here? Y. We can put y is equal to x tan theta. Can we take cos square theta? So cos square theta is equal to 1 by sec square theta, and sec square theta is equal to 1 plus tan square theta, and you can put here value of tan square theta. Oh, oh, oh. So you can keep this as it is also, but if we convert this both in the tan theta, so we just need a single value and we can derive this easily. Let's put values here. What is y? Y is minus 5. Yes. X is horizontal distance, or you can say r 100 meter. Tan theta, you can put g is equal to tan x square, distance horizontal distance 100 square, tan square theta theta. So see here only tan theta is remain. So you can solve this equation of tan theta. We just consider this is equal to x. So that you will get the form of x square plus or minus something x plus or minus something constant value is equal to 0, and you can solve x is equal to plus or minus, right. So you can solve this equation by using that. So now what? We got theta, and we need to find the velocity as well, right? So we can have SS is equal to R ut cos theta. Put value of theta here, 63 degree, and u initial velocity you need to find. Put the value of 31.32 and comment your answer. Comment your answer whether it is R is equal to 6 meter or not. I made some mistake here. And always consider teacher can make a mistake, right? All everyone can make mistake. And velocity you can have v is equal to u plus at. So this part is not required. It is just a mistake. By mistake it is here. So ignore this portion. D is equal to v plus u plus at. You can have two component of velocity. Ux is equal to u cos theta. Vy is equal to u sin theta minus gt. So you put here your answer will be there, or your answer will be there. By putting these values, you can have Vx is equal to 14 meter per second, Vy is equal to minus 44 meter per second, and you can take V is equal to under root Vx square plus Vy square, and you can get V is equal to 44 meter per second. And you can also find the angle of strike. This angle with horizontal also you may find metric alpha, beta, whatever. That is also possible. So comment your answer. Right. So tan theta is equal to Vy by Vx. You can find this angle also. So this is all for this part number 3. Thank you very much for watching Physics Doctor. Thank you once again.